I'm going to solve this question in this video, and I'll be showing you how to use Newton's second law of motion, F equals mass times acceleration, to solve this problem. And here you have a case of an object placed on this plane that is inclined at angle 30 degrees with the horizontal. Now, this is not the case where the plane is smooth. Frictional force exists between the two surfaces. And the first question says, or the statement says, if the coefficient of kinetic friction is 0.3. Now, this is a case where this body slides down in this direction along this inclined plane. So before I start solving, I want to quickly draw the free body diagram of this object of mass. Of course, you know the weight of the body will act like this, vertically downwards, and is given by the product of mass and acceleration to gravity. The mass of the body is 5 kg, so I multiply that by 9.8. Okay, that's the value of G. And then we have the normal reaction, the normal force. The normal force acts in such a way that it is perpendicular to the plane surface. This is the normal force. I call that N. Okay, if I produce the normal force beyond the plane, it makes the same angle 30 degrees with the weight line. Okay, which means I can resolve this, my mg, which is the weight of the body, into two components that are perpendicular to each other. A part of the weight acts along the plane, that is down the plane, and of course, you know that's the mg sin theta component. Okay, the other component acts at right angles to the plane, that is mg cos theta component, where my angle theta is given as 30 degrees. Okay, so quickly I can evaluate my mg sin theta, that is 5 times 9.8 times sin 30, to get this component of the weight which is acting along the plane. Okay, that gives me 5 multiplied by 9.8 multiplied by sine of angle 30. Okay, that's 24.5 Newton. That gives the force that is acting, the component of the weight that is acting down the plane. Okay, so we are told that the coefficient of kinetic friction, let me call that mu k, is 0.3. We have to calculate from the first question the kinetic friction between the surfaces. The kinetic friction between two surfaces, I call that Fk, is equal to mu, that is coefficient of kinetic friction multiplied by normal reaction. And if I come back to this diagram, I notice that there's no motion in the direction of the normal reaction. That is, if I decide to draw my coordinate axis, so along the direction y, this object does not accelerate. The only direction of motion is along the x-axis. So my normal force is equal to mg cos theta. My normal force is mg multiplied by cos theta. Alright, and I know that angle theta has been given. Kinetic frictional force here becomes coefficient of kinetic friction multiplied by mg cos theta. That gives me 0.3 times 5 times 9.8 cos 30 degrees. So that's my kinetic frictional force. So I multiply that quickly. That gives me 12.7 Newton, the nearest one. Then the next question says the normal force. The normal force, of course, is mg cos theta. That gives me 5 times 9.8 times cos 30. That is the normal force. That's giving me 42.4 Newton. That's the normal force. Okay, the next question says we should calculate the component of the weight of the block parallel to the plane. The component of the weight parallel to the plane, that's your mg sin theta. So that gives me 5 times 9.8 times sine 30 degrees. This will give me, I've found that before, 24.5 Newton. That's the component of the weight that is parallel to the block, parallel to the plane surface. Now the next question is to calculate the acceleration of the block down the plane. Now we have found the frictional force, the kinetic frictional force acting, and that acts against the direction of motion. Of course, you know the frictional force opposes the motion between two surfaces in contact. Okay, so that is my 12.7. And you can observe here the direction of action of the kinetic frictional force, which acts to oppose the motion of this block. Of course, this is the direction of motion of this block. So there's a resultant force that acts on this block of mass placed on this plane, the resultant force produces the acceleration of the block down the plane. And since I have two forces, the mg sine theta and the kinetic frictional force acting on the plane, my resultant force F will be equal to mg sine theta minus the frictional force, which is the kinetic frictional force. And from Newton's second law, this equals mass times acceleration. So that my resultant force, this is already calculated as 24.5 minus 12.7 equals the mass for the block 5 times acceleration. So taking the difference between 24.5 and 12.7, I have here 11.8 equals 5 times acceleration. Therefore, the acceleration of the body is 11.8 divided by 5. And that gives me what? Divide that by 5 gives you 2.36, roughly 2.4 meters per second squared. That is the acceleration of the block down the plane. Okay. Now that is question IV to calculate the acceleration of the block down the plane. Now the length of the plane, if it takes 3 seconds to reach the bottom of the plane, if it takes 3 seconds, time t is 3 seconds. Now we are going from kinetics to kinematics. So we come to that, and then we are going to go through the equations of motion and see the one that will be suitable for calculating, for solving this particular problem. So the length of the plane is to be found. Now the block of mass starts sliding from rest. The initial velocity is 0. And already we have found the acceleration, 2.4, because this is going to be a case of a body moving with a constant acceleration, so accelerated motion. So we're not going to use velocity equals displacement over time or distance equals speed times time. Okay, so the distance from one of the equations of motion, S equals ut plus half at squared. The block starts sliding from rest, so this is 0. So the S is the length here, which is the length of the plane, equals, this is 0 plus half at squared. Okay, so this is L equals half times, the acceleration is 2.4, the time there is 3 seconds, that's 3 squared. So that gives me L equals half times 2.4 times 9, which is 1.2 times 9. Okay, so that will give me 10.8. So the length of the plane will be 10.8 meters. So that gives the length of the plane 10.8 meters. And sometimes you can say, okay, what is the speed of this block just before it leaves the plane? Suppose you have to find the speed of the block just before it exits this plane, the foot of the plane. Okay, you can use one of the equations of motion. I think the first one will suffice here. That is ut plus et. U plus et. So that gives me v equals, this is 0 already, plus this is 2.4 times 3 seconds. So the velocity will be 7.2 meters per second. Okay, that gives the speed. And sometimes you can switch the question. You can give the length of the plane and ask you to find the speed of the block just before it leaves the plane. Okay, since the length of the plane is known and the block starts sliding from rest, to find the speed with which it exits the block, then you can use the equation v squared equals u squared plus 2as. Of course, this is already known. This is the length of the plane. I can get the speed as the square root of 2 times acceleration times the length of the plane, which is L. Okay, the next video I'll take more questions on applications of Newton's second law of motion.